We're going to build upon the last couple lessons we've had here in with multiplying fractions. And today we're going to look at multiplying fractions by both whole numbers as well as multiplying mixed numbers. And it's essentially the same process as what we were doing when we were multiplying fractions by fractions. There's just some slight differences that we need to take care of as we do this. So the process pretty much remains the same. The only difference is that when we have a whole number, in order to do the multiplication, we have to change the whole number into a fraction. If you remember when we were multiplying a fraction by a fraction, we basically took the numerator times the other numerator, the denominator times the other denominator, and that's what we ended up with our fraction. So in this case, if we have a whole number, there's no numerator, there's no denominator, so it makes it really difficult to do the multiplication. So we have to change it to a fraction, and we're going to take a look at how to do that here in just a second. Once we've done that, we're going to multiply the two fractions together. Those of you who prefer to simplify before you start the multiplication, you can do that at this time. If you don't, those of you that don't like to do that, it's fine. You can wait till the end to do the simplifying. It'll all work out in the end. At the very end, make sure you simplify though. And don't forget, just because you simplified before you started multiplying doesn't mean that your answer ends up being in simplest form. You sometimes still have to simplify at the end. Let's take a look at what it means to make a whole number into a fraction. For example, if I have a number 3, I could represent 3 by drawing 3 boxes and shading them completely in. So this model right here is a representation of 3. I have 3 boxes, everything shaded in. That's the representation of 3. But how do I make that a fraction? Well, before, when we had a box or a model, and let's say we broke it into fourths, okay? And we would shade in, let's just do 1. This model represents 1 thing that's shaded in out of how many total pieces, or how many pieces is this box cut into, which would be 4. So this fraction represents 1 shaded piece, or how many pieces we have shaded, out of how many total pieces that's been broken into. Okay, so it's the part to whole idea of a ratio there. Well, if we look at the idea of the 3 and try to apply that, it kind of works the same way. Look at how many boxes here are shaded in. And it's pretty obvious. You see that 3 of the pieces up here are shaded in. Now, my next question is, well, how many pieces total are each box? And let's think about it maybe as a piece of paper. If I hand you a whole piece of paper, you would say that you have one full piece of paper, right? If I tore it in half, you would have a half of that piece of paper. In this case here, if we're looking at these in terms of pieces of paper, how many times have we split up each piece of paper? And you'll notice, unlike the last model we looked at, it's not split into 4s or 3s or 2s. It's not split up at all. So instead of saying that there's no pieces, it's really just like a one piece. It's one piece, and all 3 of them are shaded in. So the fraction that represents 3 over 1, or the fraction that represents the whole number 3, is 3 over 1. Now, why is that? Well, let's pretend and go back to our last fraction we had or our last model where we split it up into 4s. Let's just say we split these pieces all into 4s. Okay? So now if we counted how many total pieces there are that are shaded, we'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So there would be 12 total pieces shaded in. Now, how many pieces are represented in each model? So, for example, in this box right here, and this box right here, and this box right here, what part is that? What is it split into? Well, if you look, there's 1, 2, 3, 4 in each, right? So it'd be like 12 fourths, because they're all fourths of a piece of paper or fourths of a box. The thing about it is, if you divide and simplify this fraction, 12 divided by 4 is 3, 4 divided by 4 is 1. That's a really, really, really long way of saying that anytime you're going to write a whole number as a fraction, you always are going to write the whole number over 1. So if I was going to write the whole number 4 as a fraction, it'd be 4 over 1. If I was going to write the whole number 10 as a fraction, it'd be 10 over 1. Same thing if I was going to do like 27. It would be 27 over 1. You're not going to have to do a model to represent why that works, but I just wanted you to see the math behind what makes us write the number over 1. So let's give this stuff a shot. My first example here, I have 6 times 1/2. Let me get rid of my work from earlier today during class. I have 6 times 1/2. So how would I represent 6, the whole number 6, as a fraction? If I was going to represent 6 as a fraction, I would take the 6 and make it over 1. So I can now do my multiplication. 6 times 1 is 6. 1 times 2 is 2, and I end up with 6/2, or 6 over 2. The problem is, we don't like this as an answer because this is an improper fraction. So in order for us to get the best answer and get the answer in simplest form, we need to do some division. Remember, we pretend it's almost like the fraction just falls down. The 6 falls there, and the 2 stays kind of there on its side. It's like the fraction gets just knocked over. So 2 will go into 6 3 times. 3 times 2 is 6 exactly. And we end up with 3 and 0/2. Well, 0/2 is kind of like saying 0.0 on a number. It's not something necessary we have to write. So our answer then would be the whole number 3. Some of you might be looking at this fraction and say, you could have simplified before you started, and that's absolutely correct. If you look, my cross products, my 2 diagonals of 6 and 2, these guys right here, both can be divided by 2. So 6 divided by 2 is 3, so I could cross that off and write a 3. And 2 divided by 2 would be 1. So now if I do my math, 3 times 1 is 3, and 1 times 1 is 1. Which again, if I do the same idea, 3 divided by 1, 1 times 3 is 3, and I end up with the whole number 3. It's really a pretty simple process. In order to multiply by a whole number, you take the number, put it over 1, do the multiplication, and simplify. Let's look at another example that's a little bit bigger number so we can work with. 12 times 3/5. In order to do this, we're going to take and change the whole number to a fraction. So we're going to take a 12 and put it over 1 and multiply times 3/5. Now looking at this, there's some bigger numbers up there. I want to see, can I simplify before we start? And if I look at 12 and 5, they're diagonal from each other. If I look at my 12 and my 5, they're diagonal. 5 is a prime number, meaning it's only divisible by 1 in itself, 1 and 5. 12 is not divisible by 5 because it doesn't end in a 0 or 5, so we can't simplify there. 1 and 3, can I divide either of those? Well, they're both prime. Well, 3 is a prime number, so it's only divisible by 1 and 3. 1 is not divisible by 3 evenly to make a whole number, so therefore we cannot simplify before we start this problem. We just have to work it out. 12 times 3 is 36, and 1 times 5 is 5. So we end up with this. We've got another improper fraction, and we need to make this into a mixed number. So we're going to take and we're going to divide 36 divided by 5, and 5 times 7 is 35. Subtract it, I end up with 1. And remember back from before winter break when we did to get the answer, we do the backwards check mark. So we start at the top, 7 and 1/5. So this answer is 7 and 1/5. Remember, 7's our whole number, 1 is the amount left over, 5 is our denominator. Always make sure that when you're changing from mixed number to improper fraction or improper fraction to mixed number, your denominators always need to be the same. We can't simplify in that one because we've got a 1 on top, so we're good to go. All right, you give it a shot. 9 times 2/3. Pause the video, work the problem out, see what you get, push play for the answer. All right, let's see what you did. Hopefully, you put 9 over 1 to start with. That's how you set that problem up. So let's take a look. 9 times 2 is 18. 1 times 3 is 3. And you're going to have to do some division. So if we say 18 divided by 3, Let's see here. 6 times 3 is 18. And that works out perfectly. So our answer then would be the whole number 6. Some of you might have done this a little bit differently, and that's okay. 9 over 1 times 2/3. You might have looked and said, 9 and 3, they're diagonal from each other, and they can both be divided by a number. That number would be 3. 9 divided by 3 is 3, and 3 divided by 3 is 1. So therefore, you did 3 times 2 is 6, and 1 times 1 is 1. Making this really, really easy for you to do, because 6 divided by 1 is just the whole number 6. Either way gets you the correct answer. Whatever works for you is what you should do. So hopefully you figured out and you feel pretty comfortable with multiplying a fraction by a whole number. But what happens if we have mixed numbers? And that's what we're going to take a look at now. To multiply the mixed numbers, this can be very, very similar. The only difference is, remember, we have to have a numerator and a denominator to multiply by the fraction. So in order to do so, we have to get rid of that whole number that's in the mixed number. So we do that by changing the mixed number to an improper fraction. Once we've done that, we could either A, simplify the problem and then multiply, or B, we could just multiply and then simplify afterwards as we finish. So let's take a look at what that looks like. We've got 2 1/3 times 1 1/5. 2 1/3. Now you might be wondering why I'm writing them vertically over here on the side. And that's because we need to change that mixed number to an improper fraction. If you remember from before break, we do the circle here. And basically what you're doing is you're going to take your denominator times your whole number and add your numerator. You take the denominator times the whole number and add the numerator. So up top here, 3 times 2 is 6 plus 1 is 7. And my denominator stays the same. Down here, 5 times 1 is 5 plus 1 is 6. And my denominator, again, stays the same. So I have two fractions now that I can actually go ahead and multiply. So let's take a look at what we have here. We've got 7 7/3 times 6/5. Now, if I just did the multiplication outright, without trying to simplify beforehand, I'd end up with 7 times 6 is 42, and 3 times 5 is 15. Now, those are some big numbers. I have to take 42 and divide it by 15. And as I tell you guys all the time, look for an easier way to do it. Those are big numbers. We don't want to work with those big numbers. So let's try something a little bit differently here. I notice that both the 6 and the 3 are divisible by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. Now that I've done that, I would be taking 7 times 2 is 14, and 1 times 5 is 5. Much smaller numbers and much easier numbers to work with when I'm dividing. So to convert this back to a mixed number, 14 divided by 5. 5 times 2 is 10, and I've got 4 left over when I do my subtraction. So I have 2 and 4/5. 2 and 4/5. And that is my final answer. Now, would I have gotten there from 42/15? Yes, if I do my division correctly, I would end up with 2 and 4/5. I'd actually have to simplify the fraction before I got to that point. But it's just one way that you can kind of make life easier on yourself and deal with some smaller numbers. We all would rather be multiplying and dividing with smaller numbers than larger numbers. Let's take a look at another example. I've got 2 and 1/4 times 3 and 1/3. So the first thing, again, we're going to convert these mixed numbers to improper fractions. So to start with, I'm going to take my denominator times my whole number. 4 times 2 is 8. Add my numerator, which gives me 9 over 4. Denominator stays the same. Denominator times my whole number. 3 times 3 is 9. Plus my numerator, which gives me 10 over 3. So I've got my new fractions. 9/4 times 10/3. And again, looking at this problem, if I multiply this without simplifying first, I'm going to get 9 times 10 is 90, and 4 times 3 is 12. So I have to take 90 divided by 12 to get the answer. I don't like working with those big numbers. Let's try to make this easier on ourselves. If we take and look 9 and 3 are both divisible by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. I also see that 4 and 10 can be divided by the same number, and that'd be 2. 10 divided by 2 is 5, and 4 divided by 2 is 2. Let's see what my numbers would be like now that I've got this simplified. 3 times 5 is 15. 2 times 1 is 2. Much easier numbers to work with. 15 divided by 2 is a lot easier than 12 divided by 9, or 90 divided by 12. So let's see what we have here. 2 times 7 gives me 14. 15 minus 14 is 1. So my answer then is 7 and 1/2. And I'm in simplest form because I have a numerator on top that's 1. My numbers are consecutive, meaning 1 and 2. And we all have a prime number as our denominator. So we are in simplest form. Pretty simple process, the exact same as what we were doing before, but now we just have to convert the mixed number to an improper fraction. So here you go. Here's your turn. Give it a shot. Push pause, do the work, and when you're all done, push play to see if you got it right. Okay, let's see how you did. See if you came up with the same improper fractions that I do. I'm going to take 4 and 1/5 and 8 and 3/4. I'm going to say 5 times 4 is 20, plus 1 is 21 over 5. Okay. 4 times 8 is 32, plus 3 is 35 over 4. I have my two new fractions I can work with. I've got 21/5 times 35/4. I can simplify before I start. I definitely want to simplify because 35 times 21, we're looking at a number that's going to be, up around 700 in that range. I don't want to deal with that big of a number. 35 and 5 are both divisible by 5. So 35 divided by 5 is 7. 5 divided by 5 is 1. Much easier. Still a little bit of a big number, but much easier to work with. 7 times 21, you'll see, is 147. And 1 times 4 is 4. So we have 147 divided by 4. Not the best numbers in the world, but at least we can work on these. 4 goes into 14 2 times or 3 times. 3 times would be the best for 12. 14 minus 12 is 2. Drop down my 7. 4 will go into 27. Let's see here. 6 times 4 is 24. So that's pretty good. Can we get another one in? I don't think so. 6 times 4 is 24. Do the subtraction, I end up with 3 at the bottom. So now if I do my backwards check mark, 36 and 3/4. Bigger number than what we were working with, but it's still the same process and the same idea. Okay. It's very important that we master the skill of multiplying fractions because as we move into division, it's going to rely very heavily on your ability to multiply fractions. So if you have a hard time with these or you're not understanding the multiplication part, please come in and see me. As always, I'm available before school, during lunch, or after school. Just let me know you're stopping by or swing on by, and I'll give you all the help that you need. Until next time, hopefully you guys learned something, and hopefully this helps.